Part of the L'Hopital's rule is not L'Hopital's rule advanced. It's L'Hopital's as you should already know it, but knowing when to use it is kind of nice. This first limit up here, you should know that we always do what when we're taking a limit, no matter what. And last year's, as long as this is refusing to go full screen on me right now, I'm going to show you one of last year's free response questions. This guy right here has a reader for this one, actually. This was on AB, I think. Does this look familiar to you? I don't remember. Maybe I don't remember. But many kids assumed that this was indeterminate, and they went and used L'Hopital's rule, and they knew the derivative of arctan, some of them, and they went, I don't remember if this was a crossover, but I mean, I think it was BC and AB, because I remember Kev coming in and saying something about it, and the kid said, well, no, that wasn't L'Hopital. And so he had L'Hopital'd it, and it wasn't a L'Hopital problem. So he's like, because the very first rule is you plug it in, and all of this worked out nicely if you plugged it in. And College Board is on to the fact that I think a lot of people just assume they're going L'Hopital's because they always do, so they threw kind of a loop. So, you know, most kids caught it, but there are a lot, I think. Do you guys remember this one? I swear this was a crossover because I graded number 3. So it's an ABBC crossover question. Yeah, and this is all AB content up here. So you guys must have had this one. You probably don't remember. But you might have thought it was real easy and L'Hopital'd it. You can get all of this by L'Hopital'ing. So be careful that you always plug stuff in, because again, sometimes you get a viable answer. So that's got to be same with on your worksheet today. God dang it. Oh, there we go. Oh, dirty dog. There, thanks. Thank you. And now it's blank. Now what? God dang. Oh, spinning wheel. No, just a second, I'll get it. All right, I think I just need to go back one. There we go. All right, so what we do first is actually kind of important. Make sure you always plug it in, but this one does yield. So go ahead and plug it in. On your worksheet, though, some you can just plug in and get an answer. So watch for that. Plug in. This guy yielded 0 over 0, which is actually one of 7, arguably 8 indeterminate forms. It's just the only one of 2 that you guys have had so far. There's other indeterminate forms. I listed them all here. I'm not going to ask you to list them this year. It doesn't really serve any purpose, but these are all considered indeterminate. Like, they need further work when you get them to figure out a definitive answer. So be careful, like 0 to the 0, I guess I would think maybe that's 0. It's not. Maybe it's 1, because anything to the 0 power is 1. I don't know, it needs more work. So all of these are ones that require a little bit more work, but L'Hopital's rule can only be used on these 2. So when it doesn't result in one of those 2, we're going to have to play with it a little bit. So it can only be used on 0 over 0, or plus or minus infinity over plus or minus infinity. So if you can get it in a form that would yield these 2, you can launch into L'Hopital's rule. And I think we remember what it says. You just do the derivative of the top over the derivative of the bottom. Yeah. No, good question. It can be positive, and we have a couple today where it's positive infinity over negative infinity. This I could have put on AB's last test, though, because you don't have to choose L'Hopital for this guy. By the way, remember last year I stressed do not do this, right? Do you remember? And I said they've been really picky with College Board doing this, because then once you get the answer, this one ends up being 5. So if you keep stringing it and you end up getting 5, what are you in essence telling me? 0 over 0 is 5, so you don't get the answer point for that. What they want you to do, if it's an if it's multiple choice, who cares, right? But if it's an FRQ, do you remember how I told you to write it last year? Yeah, if it's an FRQ, you actually have to. Now, we're not doing FRQs. You're going to be on my worksheet today. But if you have an actual FRQ, we'll do just one of them the correct way so TJ can see it because he hasn't done it before. If this is one in part of a free response question, you have to state that you know the top is resulting in 0 separately from stating that you know the bottom is going to 0. They do accept, but I don't know that they always will. So I would write this. They have said that this was okay in the past because at least it's better. At least it's a kid trying to tell me that they're going to 0. So in the past, this notation's been accepted, but that could change at any time. This is how they tell me to tell you. You know what I mean? They always send out AP things. They say, you teach it this way. So I am going to teach it this way, but if you did all of them on your worksheet that way, you get really grouchy. So we're going to have to just know how you have to do it in the event that you have to, because I don't want to do this every time. Are we good with that? Do you remember last year what else I said you had to write? Therefore, by L'Hopital's rule, yeah, you had to sort of state that you were using L'Hopital's rule. And I'll tell you what I'll allow you to do on my test for that, unless I give you an actual FRQ. And L'Hopital's can be spelled historically one of two ways. So I'm going to stick with La Hospital. Sometimes the S is out and there's a little squiggle thing over the O. But anyway, you would just take the limit. This is the only one I'm going to show the full blown of the derivative of the top, which would be 6x minus 7 over the derivative of the bottom, which is 1. So this is just going to be a nice 5. Don't lose track of what you found. It means that since the limit is 5, if I were to graph this function on my calculator, correct? Do you know what it would be? If I entered this in y1 and hit graph, what do you think it will graph? It's a great question. Let's go do it the other way, because if you do it the AB way, you can't help but see, right? Watch, if you do it the AB way, they could have easily had this on their test last month because they didn't know L'Hopital's rule, but then because there was a 0 living on the top and the bottom, I had to be able to suck an x minus 2 out of the top because it was causing, see what I mean? There's my 0 over 0. So then once you factor it, what would that be? 3x minus 1, right? Gone, gone. This is really what it is. So now I'll ask you, you lose the visual with the L'Hopital's, right? If I were to graph this entire function on my graphing calculator, what will it make? A line. It'll make this line, right? What will be true about this line at 5? There's a hole in the graph. So sometimes, it's good to review the AB as we go, because sometimes they'll say what value should be assigned to 2 so that the function's continuous. That's actually saying plug up the hole in the graph, right? And make f of 2 equal to what? 5. Yeah, so watch the questions, but we could have just factored that one. Same here, I'm not going to go through this whole one, but if I plug in the -3, I will allow you on the worksheet just to go like that. No, if you don't get, by the way, what do you have if you get this on direct substitution? It's not indeterminate. It's not 0. It means there's an asymptote there. And then we have to make a decision, right? At an asymptote, if it's one-sided limit, you can only be infinity or negative, right? When do you put D in E? Just as good AB review. When it's one of each from both sides. Yeah, we're all going like this. One of each from both sides. But I'll allow this on the worksheet today. You're just telling me going to 0, we're good. All right, this guy right here in AB, do you remember? I'm not going to do it the AB way, but do you remember what you could do? Because you don't know L'Hopital's rule, pretend. Multiply the top and the bottom by the of which term? The bottom. So we're not going to do that. We're going to go by L'Hopital's rule. So I'm giving you what I would like to see on your worksheet today. You don't have to say going separate, therefore by L'Hopital's rule. Just give me the arrow, the LH, and I'm good. And then just go ahead and launch into L'Hopital's really quickly. The top is going to go to 1 with L'Hopital. The bottom, I would maybe go off to the side. AB just started chain rule today, but you guys should be very, very fluent in taking the derivative of that guy. Right? What's it going to be? Almost. So yeah, it'll be 1/2. Don't forget the inside link though. So it is 1 over the square root of x squared minus 2 with a 2, but times 2x, yeah. So let's get this guy out and this guy out. So won't it be, watch my arithmetic mistakes. I made a couple last hour. I tend to go fast when we go back to AB. I make more mistakes in AB than in BC. But this would be just x over square root of x squared minus 5. And then you would replug, etc. I don't think I need to do the arithmetic. So how else could I have done this one? With AB conjugates you can write, or you don't need to fill it in. So let's go to the next page. Go do this guy. Go first of all, decide if it's L'Hopital worthy. All this stuff is just the history off of Wikipedia for the spelling of some of it. L'Hopital can be spelled a couple ways. I don't want you to think like I'm going in and out of spelling it correctly. So go do this guy really quickly. It should go fast. I can probably cruise through the AB here. we are going to 0 and going to 0, so by L'Hopital's rule, you should be able to launch into a new limit, and I'll let you guys do it and tell me what the answer ends up being. We're all getting a 0. There's a 0 on the top. What does there end up being on the bottom? A 3. Okay. So are we all getting 0 over 3? What's our answer then? What does that mean about the graph? No asymptote. There's a hole. It's on the x-axis, right? If I were to graph it in Desmos and zoom into the x-axis, where will I see a little hole on that? 1, 0. I just don't want you to lose track of what you're finding, because L'Hopital's rule, it's going to get really messy and you're going to lose track of what you're finding. This guy right here, again, we would plug in the 0 real quick. Just do it in your head. I've got 1 plus 0 minus 1. I've got 1 minus 1, boom, therefore by L'Hopital's rule. I'm going to take out all that writing and allow you to do that on this type. All right, so then by the way, what would you get wrong if you did this? So I'm going to go ahead and write this. This would be e to the negative x and then a negative, and it was negative. If this was an FRQ and I'm reading it, what do they instruct me to do? And linkage always, they brief you forever, but linkage errors are traditionally, they get taken off the answer point. So, and it can only happen once in a problem. So if you have 2 linkage errors, you only will lose that answer point. But these 2 things are not equal. Their limits are. So again, be sloppy today, but not too sloppy. Tomorrow you can't be sloppy at all. So then when I do a replug on here, it looks like I'm getting 2 over 1. So notice we have the indeterminate form of 0 over 0. It's already yielded 3 different answers. A 5, right? A 0, and now a 2. The other indeterminate forms work really similarly. Do I need to do this guy? Yeah. Right. Yeah, but that was a big issue at the end with, well, it's always is an AB, and usually what I tell you is once the variables are gone, you don't need the limit anymore. So if you plug it in your head, that's fine. Or even if I plugged it in, if I went like this, e to the 0 plus 1 over e to the 0, because the variable's gone, you can drop the limit. All right, good question though. All right, so we're not going to do that next one. I think you got it. So here's one thing to be very careful of. And I always tell kids, and then all of a sudden it popped up for the first time ever on your AP test. They threw a loop on an FRQ where direct sub worked. And not half, but a huge chunk of kids would do L'Hopital's on it. So be very careful. Like for example, this guy, it looks like it's going to go L'Hopital-y, so you kind of just assume it will. But when you plug this in, you end up with the sine pi over 1 minus cosine pi. What is the answer to this actually? 0 over 2, right? This is just 0. So that one's 0 and you're done. So number 1 rule, and you can't forget about it because it actually truly is, don't get so sloppy. Make sure you plug in your head first and convince yourself that you have the indeterminate form. And if you launched into L'Hopital's, it doesn't give you 0. Do you just trust me? Because we didn't get much homework time last hour, so I'm trying to give you guys a little bit more. So just trust me, it was not 0. It was actually in infinity. So be very careful. L'Hopital's only works. Now also, don't use it when you don't need it, even if it applies. Because for this guy, the top's going to infinity and the bottom's going to infinity. So I could L'Hopital it and then L'Hopital it again and again. But view it as rephrase it, and you can do it with pre-calculus. Limits at infinity are actually calculus notation for horizontal asymptotes. What's the answer to that? 2/3, exactly. So you could L'Hopital it and it'll yield a 2/3, but it's not necessary. All right. Same over here. I could L'Hopital it and I'll get the correct answer, but it's not necessary because I always call it survival of the fastest. And these are growing at the same speeds for the most part, so I call them tied. So I just steal it. Same here. What is the square root of x squared? It can be. It's either x or it's negative x, and it matters which infinity you're approaching. So if x was negative, like say -4, I'd square it, get a 16. Its root is actually -4, so it's this guy. So if you're approaching infinity, the square root of x squared is, for all shits and giggles, it's a net. Oh, I'm recording. Oh! Just cause, hopefully, it can be replaced with an x, right? Now, take a look. As I'm approaching infinity then, what's my answer? 1. So I don't need L'Hopital. So be careful. There's a couple things with L'Hopital's rule. Don't apply it when you can't. Don't apply it when it makes more work for you. And moving on to the next page, this guy, we know, just 2/3. Watch that approach. Now this guy, you can't, when you plug in the infinity, kind of, it's a number, but this top's going to infinity and the bottom is. So this is definitely a L'Hopital's candidate, but I'm going to tell you also, you shouldn't need it because it's all about, when we talk about functions more in our series chapter, it's all about who grows the fastest. So you need to kind of in your brain, if you can get a hierarchy of functions, you can do a lot of them in your head. For example, what do you think the slowest growing function is? That's the second slowest. Yeah, natural log is really slow. We're going to call that ln when we get to our series, but for now I'll use an x. But that's a very slow growing function. If it's on the top, you're almost always going to go to 0, regardless of what's on the bottom. If it's on the bottom, you're almost always going to go to infinities because it is survival of the fastest growing function. Constants are the slowest. And think of L'Hopitaling a constant. What does it immediately happen with it? A 0 if it's on the top and your answer is 0. If it's on the bottom, you're dividing by 0, which means you're heading to the infinities. So this guy gets slammed. This guy's a wimp too. The next one that's kind of in the middle is the one you see the most often, all these polynomial functions. I'm going to call it x to the n. They grow fast, but not as fast as some others. So for example, if natural log is battling x squared wins. So I don't need to even L'Hopital, I just kind of know, right? If this one's on the top, going to 0. If they're swapped, I'm going to the infinities. Would you agree? Now, what do you think the next guy is? Yeah, but not necessarily e. So let's call it n to the x, like some number. You wouldn't think that one grows faster, but even if I'm considering like x to the second versus 2 to the x, at first this guy seems at 1, this is 2, 2, this would be a 4 and a 4. If this was a 3, that'd be a 9 and an 8. This one seems to be holding its own. Even when I get to a 4, it looks like I'm at 16. They're still tied. Like, doesn't seem like it, but right even at 5, 32. Let's go to 6. What's so 36 and 2 to the 6 is 64. You'll see it start to separate right away, and that's the lowest base. Well, aside from 1, right? So they will separate. The next one, which is going to be huge for us in our series, factorial, you're going to hear me say a lot, factorial is king. It's actually not king. There's a kind of a kingier king. But factorial is the one we're going to see a lot that just slams every other function it's paired with. It just kills them. The other one after that is actually n to the nth. Think about it, like 10 factorial is 10 times 9 times 8 times 7, where 10 to the 10th is 10 times 10 times 10 times 10. So that guy's king, but we only see him like once this year. This guy doesn't come up very much. Factorial is going to be the killer later. But why am I going through all this now when it's actually part of our series discussion? Is because it allows you to do these in your head. That denominator is going to slam the numerator. What's it going to? Done. I could L'Hopital it, and eventually what does the polynomial on the top go to anyway? 0. They had one in some practice test you guys took. It said, which one of these has a limit of 0 or something like that? This guy. What's its limit as I approach infinity? 0, because it doesn't matter. I could put even these on here. I could pair it with a natural log, and that's not going to pull on it enough. So you can do a lot of them in your head. So now what if they don't pop up in the traditional form? Like the question is, well, what do you do if, number one, it's not survival of the fastest, or you don't have a L'Hopital presentation? Take a look at it. First of all, why do I have to approach from the right for this function? Because natural log doesn't exist to the left. So that's not a typo. That has to be there mathematically. So make sure you write domain, maybe of natural log. You're going to have to watch that because you'll see some of them are one-sided limits and some are two, and it's usually because the two-sided violates a domain issue. Are you good with that, Bethy? Now watch what happens with direct substitution on this. I would have x, which is 0, times, and I'm taking the limit as I approach from the right. What's natural log going to as I approach from the right? Negative infinity. This is one of those indeterminate forms. You can't use L'Hopital's rule on it yet. So I got to tell you this guy and another one today. I'll do the other ones tomorrow. They get harder. I'm doing the two easier, not quite L'Hopital's, like you couldn't have done it last year, but it's not too difficult. So let's take that. I'm going to write that guy down again. It was x ln x, correct? Right now, I'm getting an indeterminate form and I can't work with it. So one of the tricks of the trade is to take it and instead of writing it as a product, write it as a quotient. And you have two options and I'll tell you which one I choose. I choose to keep what I consider the messier function. Like I think natural log just looks a little messier. I like to keep that one on the top. And then I'm going to divide by 1 over x. I'll have the exact same expression, but yes, 0 from the right. Yeah, thank you. I just thought, when your hand popped up, I'm like, I felt like I was writing something wrong. All right, so all I'm doing is rewriting this product as a quotient. Now take a look at the indeterminate form I now have. This guy, and I'm going to have you write them down, so be careful. I'm going to tell you once you get to a test, I'm going to say, I want to see that you know what indeterminate form you're getting. What's the top going to? Negative infinity. What's the bottom going to? And think of the graph. It's the graph of 1 over x. And as you approach 0 from the right, what's it going to? Infinity, or be a creeper. If you don't know the graph, pick something really close to 0, like like a millionth, and that would multiply by a reciprocal, a million. So either way, I would want to see this. That's actually a point for me once we get going on them. I like to know that you know what one you got. This is L'Hopital worthy right here. So now you can go ahead and L'Hopital it. I feel like I'm missing, I have to scroll a little bit. So now, again, I always go ahead and just do that for me. Just tell me you're launching into L'Hopital's rule so that you're not telling me the functions are equal. Their limits are equal, right? So natural log's derivative is 1 over x. And what's 1 over x's derivative? There you go. You have a good memory. Negative 1 over x squared. Multiply by a reciprocal. And they're going to cancel. Looks like I'm going to get negative x. So this is actually reducing. Actually, if I wanted to graph it, it's this guy, right? But what happens as I approach 0? What do I get? 0, right? I'm going to get 0. That's the answer, which is what maybe a lot of kids would have guessed for this indeterminate form. But on the next page, you're going to see the same one yields a different number. So you can't just assume 0 times infinity is 0. I'm cruising compared to last year. I'm almost done. This guy's just like the previous one, and you seem to get it. So we'll write sim to previous. All right. So I have 2 more. I think. This guy right here, again, I want to see the indeterminate form that you're getting. When you plug it in, you get infinity times. As we go to infinity, this would go to 0, right? And what sign of 0? 0. So I'd like to see that you know what you're getting. I'd also like to see, you should know that I got to fart around with it. What I would do, again, is I would keep the more complicated one on the top. That generally is best. What do you think? Yeah, I consider the sign to be a little bit more complicated. What will I divide it by? 1 over x. Perfect. I haven't done anything yet, actually. I've just done a rewrite because now when I go to infinity, look what I'm getting. 0 over 0. And I want to see that. Just a little off to the side is good for me. And again, if it's a free response, which they've never had this kind, but I never know, right? Anyway, so now we're going to take and we'll L'Hopital it and just write a little LH over there to ease your writing. All right, let's go do it. Derivative of sine, Nordy. Cosine, and then chain rule it for me as well. So times, perfect. Negative 1 over x squared. I don't know whose mouth that was coming out of though. On the bottom, it's the derivative of 1 over x, which is also negative 1 over x squared. It kind of worked out nicely for me. This happens a lot with this process, by the way. You chain rule the top, and you end up being able to, it's going to happen tomorrow when we derive what e actually is. We're going to have a similar thing popping up in there. So this is really cosine of 0. So notice that same indeterminate form of 0 times an infinity, when I did all my work, came out to be 1. Who in the world would ever guess that? And it's not what this equals. It's what the function approaches. So you got to be careful. But that's my one trick of the trade. If you get one of those 0 times the infinities, rewrite it so that it's a fraction. Next trick of the trade is this guy's also an indeterminate form. Again, it's all about how fast you're going to infinity. So if this function yielding this one is going faster than that one, it will never be 0, right? So it's about not a number, it's about getting as far as you can at a certain speed. That's what infinity is. So when I plug this guy in, secant is 1 over cosine. This is going to end up being 1 over 0. This one's going to infinity. You know there's an asymptote for tangent. You should know that one's going to infinity. But that's giving me this guy. So here's the trick for this one. I can't use L'Hopital's until I can get a fraction. So kind of keep that in your mind for all of them. You can't use L'Hopital until you can at least get a fraction. So we're going to write secant as what? You can anticipate what I'm going to do if I'm telling you I have to get a fraction. 1 over cosine, yeah. 1 over cosine. I'm going to write tangent as sine over cosine. Then I can get a single fraction. I don't even need, last hour I started crisscross applesaucing it, and they're like, what are you doing? I'm like, oh yeah, I'm too, step back, LaRude, right? That's just 1 minus sine x over cosine x. So I was being a doofus, which happens sometimes. 1 minus sine x over cosine. Am I going too fast? I feel like you guys are getting it, so I'm trying to, you're nodding, Ches, so I think we're good. Now, I didn't really do anything yet. This is all the same stuff. It's just been given a facelift, and remember why I gave it this kind of facelift. I'm trying to get it L'Hopital worthy. I'm trying to go to one of these, and I want you to write down which one you're getting. For this guy, what's the top going to? 0. I'm fine with you just doing that. And the bottom's also going to 0. It's now L'Hopital worthy. So then I'll allow you just to do this just for me. Again, I can't stress that enough because I don't want to send you into the AP test and have you lose easy notation points because I've been sloppy, but it's a pain in the butt to write that all the time. So I'm good with this. Anyway, I'm going to take, what's the derivative of the top while I'm talking? Derivative of sine is cosine, so I'll have a negative cosine. How about on the bottom, a negative sine, right? So top 0, bottom negative 1. So what's the answer? 0. So this guy ended up having infinity minus infinity as its first form, resulting in 0. But guess what? The next one won't. So go ahead and start this one and see how you do. It's our last one. It was about 50-50 last hour, so be careful with it. I'll start it really slow. If you're listening to this, you absent people, they're doing it while I'm doing it. Do I want to do product rule or distribute? If I do product rule, if I distribute, I'm going to have to do product rule anyways. Let's just do first, second, second. I got another iteration. You guys getting a double iteration of it too? Yep. Don't forget to tell me you're doing it again. Just you don't need to write it out in words. Just a little LH will do it. Oh man, I gotta do product rule first, D second, second D first. I'm getting a -1/2. Yes? You all got there faster than I did. We're ready to be done then. So -1/2 is, notice it was the same indeterminate form that up here yielded 0, so don't assume what looks good is good. I told the last hour with this worksheet number 8, if you're gone, by the way, I will scan it, look for it in Schoology. I told them you can be as sloppy as you want. I rarely say that. But I'm going to force good notation on you tomorrow for the ones that actually need it. These are kind of, you do you on this one. I'm concerned about answers only. Be careful with that. Make sure you do as I said, not as I'm telling you to do. Make sure you do initial plug-in in your head because some of these you're done. So some of these you do not need to launch into L'Hopital's rule, but if you do, you don't have to write it out formally. You can even drop your limits. I mean, I'm probably making mathematicians of the world roll over in their grave right now, but the point of this first page, front and back, is to remember AB limits, and I taught you well in AB, so you should know how to do it well. I'm just saying you don't have to do it well. It takes you 3 times the time. So correct answers is what I'm concerned about on the first page. Once you start having to play with it, I want to see what you're doing. Like, don't do the whole thing in your head. But you go ahead and just go as fast as you can. If you choose to fact or cancel, I'm fine with that. Do you guys like L'Hopital's rule better anyway, just on all of them? Yeah, I probably. But there's a couple on here when you plug in. Like I can see even on number 3, I plug the 3 in and I have a 1 on the bottom. So that's definitely not going Lopi. All right, have at it. Go as fast as you can. The first page took them about 5 minutes last hour, but that's all the time they had to work. I talked a lot more. That can go in there. Oh, I'm going to turn this off. It is? It's right there. Nope, the orange. I got a new one. I got a real one.